Look at a traditional database setup. Before you can query a single file, you usually have to set up a dedicated server, open ports, and configure connection strings. That complex network adds friction to every single query. DuckDB UI takes a completely different approach. It drops the heavy client-server architecture and replaces it with an in-process visual workbench that runs right on your local machine. Over the next few minutes, we are going to download the DuckDB engine, launch an interactive NoteDuck, and visually profile hundreds of thousands of rows of data. By removing the network round trips and the server setup, you can move straight to exploring your data. You cut out the waiting and get right to the engineering. First, head to the DuckDB installation page. You'll want to select the command line environment and choose the correct package for your specific operating system. That gives you a zip file. Extract the DuckDB executable into its own dedicated local folder. Keeping it isolated here saves you from dealing with system pathing configurations right now. Now open your command terminal directly inside that exact folder. If you open a generic terminal window in your root directory, your machine won't know where to find the application if you just type the standard command. You get a basic text prompt, but if you append the -UI flag, you bypass the text prompt and initiate a local web server. The terminal displays a local host port routing, and within seconds, a browser tab pops open displaying the welcome page. You haven't connected to an external cloud or a remote server. You've turned your own hardware into a standalone, isolated analytical environment. Once the browser tab opens, click into the default Welcome Notebook. We are going to load a raw local Parquet file straight into memory. We don't need a traditional schema creation script. We write a simple SQL command to create a new table and point the selection directly at our external file pathway. Hit Ctrl-Enter to execute the cell. Almost instantly, you'll see a total row count appear beneath the cell, and your new table populates over in the left-hand side panel. Bypassing the usual database prerequisites lets you interrogate the data the moment you get your hands on it. Next, we can examine the structure of this dataset. Usually, you would write a series of repetitive queries to check for null values or distinct counts. DuckDB UI replaces that with a visual diagnostics tool. Go to the side panel and click directly on one of your new column names. A panel slides out, populated immediately with the column's distinct values, minimum and maximum ranges. This chart shows a complete data distribution histogram mapped out automatically. These insights required no manual SQL queries. Condensing your exploratory data analysis into a few visual clicks trims hours off of a standard pipeline development cycle. Now let's organize our work. Click the plus icon to create a brand new interactive notebook and give it a name so we can store our custom analysis. In the first cell, we'll write an aggregated query. We want to select the record type and count the total number of records for each type. Then we add a group by statement to organize those counts. As you write, double-check your formatting. A missing space or a typo in your column alias will cause the execution to fail. Fortunately, the interface helps you along. As you type, an auto-completion menu drops down to suggest the exact SQL keywords you need. Run the cell, and your query results appear directly beneath your code in a clean, formatted data grid. Keeping your queries isolated in these executable cells creates a reactive, document-driven layout. You can adjust one piece of logic without having to rerun an entire script. We've gone from a raw local file to a fully profiled, interactive notebook, and we did it without spinning up a single database server. Because everything executes directly on your machine, your sensitive development data never actually leaves your local environment. The SQL dialect you use here is also the exact same dialect required by remote cloud analytical stores, like MotherDuck or S3 Object Lakes. You can prototype your pipelines locally on a small sample dataset and push that exact same code to production with zero refactoring.